Hi, thank you for joining me. This is a talk on craftsmanship in test. It's one that's been given in a bunch of different forums to a lot of great feedback, and many people have asked us to be able to present this in a way that they could share. So that's what I'm going to do. It's a talk that's been given by my business partner, you can see here, Steve Ropa, and by myself. I love this picture for this talk because as we're talking about craftsmanship, I am right now in a Scotch distillery in Scotland. And I'm holding in my hand a dram of outstanding Scotch. It had just been pulled right out of that barrel that I'm leaning on. It was fantastic, and so it just speaks well to the topic. Together, Steve and I founded the Rocky Mountain Programmers Guild. That's kind of our passion project in being able to provide mentoring and coaching and skill development opportunities for programmers through the course of their careers and be able to help them achieve new levels of performance and be able to build a happier, more effective career out of it and be able to deliver more value to their companies. So definitely look us up if we can help your business or you out. Now, normally when I have this talk, one of the things I say at this point is, please, let's make this a conversation. Stop and interrupt me. Let's chat. Obviously, that's not going to happen while I'm doing a video recording. However, I still do actually want to have a conversation. So however you stumble across this, if on the video site or on LinkedIn or whatever it is, Twitter, reach out to me with your thoughts because I'd love to hear what you have to say. I'd love to be able to talk to you about it. It helps me be able to flush them out more or find where the holes are. And I love being able to support people wherever they're at on this stuff. So definitely don't hesitate. So if we're going to talk about craftsmanship, we have to kind of start with a fairly central question. The question is, what is craftsmanship? What do we mean by it? When I realized that this was an idea that really resonated with me in terms of what we do in building software, I didn't realize it would evoke so many different reactions from so many different people. So I think it's really important to take a minute and define what I mean by craftsmanship and how that applies to software development. Hate to do it, but going back to dictionary definitions is a place to start. Let's break it down the word and just look at the word craft. Oxford Dictionary defines this as an activity involving skill in making things by hand. I like that. We're not just turning the crank on the meat grinder here. This is something that we are having to put some skill into what we're building, what we're creating. We're creating something that didn't exist before we started, and we're bringing our skill to the table. So why not stop there? Let's just talk about excellence in craft. Why use craftsmanship? Let's look at the other part of the word. I don't love that this is a gendered word, but it has such a rich context and history that I think adds an important flavor to the conversation. Merriam-Webster defines this suffix as meaning skilled engagement. Now, this word skill has come up now twice in the same definition, and that's not by accident. It's kind of important. When you start talking about something that's a reflection of craftsmanship, it is a reflection of something that's being executed at a higher level. I have 3 children. My son loves to do origami. My youngest daughter threads Cheerios on yarn. They're doing crafts. That's not what we're talking about. It implies a level of maturity in our practice and a level of execution in our skill that's not casual, it's not hobbyist, it's something that we're doing with some serious investment. Other uses here of this, talking about marksmanship, obviously again, very skill focused on the amount of practice and effort it takes to become a fine markswoman or marksman. Horsemanship, sportsmanship, all these same ideas of almost taking your skills to excellence at a professional level. I'm not alone in using this term. The Manifesto for Software Craftsmanship has been out for almost a decade now, and it's structured almost to be in addition to the the Manifesto for Agile Software Development, adding ideas about practicing our craft, helping others learn it, the importance of well-crafted work, and steadily adding value, not just continuing to run in circles. These add some elements of judgment to them. I don't love the wording on well-crafted because we're using the word in its own definition. I would almost say well-made or well-built. Feels like it would be a better wording there, but maybe I'm splitting hairs. Regardless, when I look at this stuff, I look at the manifesto for agile software development. I look at software craftsmanship. I look at all these things. It feels like there's a really, really big piece missing. If you're watching this, there's a good chance that you already have it in your head, and that's, where's test in all of this? How does test fit into all of these pieces? One of the attributes of software being well made is its ability to handle change. And it's why it's kind of fundamental to agile software development. If we have a plan that can adapt to changing needs and changing requirements and changing technologies, the product has to be able to, the code, the work, the thing we built has to be able to do the same. And if you take that as a definition, then I would almost say that your test, and definitely your test automation, almost has a, not almost, it has a greater need for being well made and well crafted than the product itself. I realize that's a kind of a controversial statement because the product is what the customers are using, right? That's the part that the money's being spent for. But the product has to change in the face of the changing business needs and all of those things. And so the application code has to be well crafted. But the test has to be able to handle all of those changes as well as all the change generated by the application development. So all of the technology changes and all the structure changes and all of the interface changes and all of the things that are at that layer where the tests and the application touch, all of those changes impact test and test automation as well. That means that rather than being the we don't have to worry about building that well conversation that so often happens in tests, it's just tests, it's no big deal. It actually kind of turns it on its head and says, we really have to make that well because it's tests. Now, in this conversation, I'm probably going to talk a lot to test automation. And that's because I work more with programmers, not exclusively with programmers, but more with developing programmers. And test automation, in my opinion, is just a different domain of application development. You have UI developers, you have back-end developers, you have mobile developers, you have test developers. It's 90% the same stuff. However, everything we're talking about also applies in other testing roles. And so if I forget to say that, please know that that's just the flow of consciousness and not because that isn't meaningful or there. So looking at people who are really, really effective in software, and after having worked coaching and leading and helping support programmers for almost 20 years, and my business partner doing so for longer, we kind of sat down and said, what are the things that make people more effective? What is that 10 times more effective performer you so often hear mythically talked about? What are they bringing to the table? What are the things that are necessary to excel? And when we took those and we found that what was underneath there was, go figure, something we've already discussed, was the skills that they're bringing, not the knowledge, not even the experience, but the skills that they have built out of those things. And it was a fairly diverse set of skills. So as we started breaking them down and trying to factor them out, we found that these 5 different pieces emerged out of the puzzle. So we started building a model. This is step 1, which is these 5 different facets, different dimensions, what have you, of skills that we're bringing to the table. Top one being the craft of what we're building. Obviously, for programmers, automators, we're talking about, to a large degree, code craft. Can we handle flow control and data structures, coupling and cohesion, dependencies and scoping, all of those different pieces, design patterns and principles, and they go into a well-made solution. And it's easy to stop there if I'm using the term craftsmanship, but that's only one piece of the puzzle. Technologies and tools I often describe in the same breath because they're kind of 2 sides of the same coin, but they're not the same thing. Technologies are all the things that I build my solution out of. They're the things that get shipped out the door. When you click run, this is what you're getting. So that would be your languages. Are you working in Python or in Java or in C# or in Scala or in JavaScript or what have you? That would be one of your technologies you're building with. What libraries are you using? If you're building test automation, are you using Selenium? Are you using Cucumber? Are you using Water or Fitness, or probably half a dozen other outdated things I could list? Those are the building blocks that I'm making my solution out of. On the other side of that, are the tools that I'm making it with. These are the things that I need to be extensions of my hand and my thoughts to be able to do the construction. So this is my IDE and my version control and my continuous integration and all of that kind of stuff. Lifecycle, I kind of don't like the name of, and I keep wanting to change it to like software dynamics, because it's all of the pieces about knowing what you're making. How does software get incepted? How does it born? How does it grow? How does it stay healthy? How does it get exercise? How does it get sick and rot and die? All of the pieces of how that takes place. So some processes absolutely fall in there, but I think there's a lot more meat there. And the last one is the professional. It's those things that I need to bring to the table that are not necessarily just about software. They're about being able to perform in a professional way. So their estimation and planning and collaboration and communication and all of that type of stuff. Now, taking those facets, that's great to have all these skill areas, but how do we move them forward? How do we know where I'm at and where I need to go? And this is where I was really thankful to be introduced to the Dreyfus model of skill development. Now, Dreyfus was developed by the Air Force in the 1970s, and they made it so that they could more effectively train great fighter pilots and things along those lines. And they were looking at how skills grow. It was more almost research than development. It was looking at how do people learn skills, not what is my magic wand for getting them there. And they broke it down into 5 levels you can see here, going from novice to master. So as an overall picture, you see we have almost a graph plot that starts with what are the skills in what are the regions and what level is it at and how does that region move from boop. How do I start with, let's say, version control as a novice and move to competent, and move to proficient, move to expert, move to master, kind of my master sphere contracting. We call this our mastery wheel. As we're talking through this, I hope that you'll take some time and think about your own skills. Think about what skills you have or you wish you had, where they fit into those categories, where you realize you haven't thought about what categories. We're going to talk about how what each of those levels means so you can help get an idea for yourself of where you are and what it means to move them forward. So to do that, I've got to dig a bit into Dreyfus. Now, Dreyfus is kind of an academic research work, and so it has a lot of big words that don't always communicate clearly to me. Maybe they do to you. But I want to approach them from 2 ways. First of all, I want to use examples. I'm going to use one example of developing a skill through these levels. And the other way I want to do it is I want to talk about your brain. If you imagine your brain is like a computer and you have a certain amount of RAM, you have some working memory, you have space where you can hold ideas that you're actively working with, and it's a fixed and limited amount of space. As we start working our way through these levels, we're going to be talking about what we're using that space for at every level and what changes to be able to move that forward. So if I start at this first one, the big words they like is non-situational recollection. Non-situational recollection means basically if I'm learning something, I can remember that I have the knowledge about it. If you gave me a test, I could answer, what is a switch statement? This is what a switch statement does. There's 2 aspects of that. It's that I'm focusing on, I know the features of this skill that I'm working on. I know the basic rules for the skill that I'm working on. And that's what's filling that working memory that we're talking about. That's what's filling up our brain space. To use as an example, if I'm talking about learning about conditionals in code, and I'm at a novice, this is the type of things that would be filling up my brain space. What conditionals are there? There's ifs, and there's switches, and there's if-elses, and that type of stuff. I'm going to remember that a switch can only branch my flow on one expression. I can only do it when I have discrete values for that expression, and I'm remembering, don't forget the break after every case statement in my switch. And I've got, these are the rules, that's my rule, don't forget the break that I put in my head. These are the features of how these conditionals work. This is a novice level on conditionals. Absolutely great. When I go from novice to competent, I'm going from non-situational recollection, which is I can regurgitate all those things if you ask me about them, to situational recollection, which means I realize this is where I need one. In order to do that, I've got to free up brain space. In order to free up brain space, there's no shortcutting this. It is practice and more practice and more practice until you can take those things that are in your working memory that you're having to think about and move them to more of an automatic space, almost like a muscle memory type of space. And as I do that practice and those things become more automatic, suddenly I'm freeing up that brain space and I can start paying attention to the context of where this goes. And that's where I start getting into the competent. And on a switch statement, I would say, I'm writing a method, I need to do something. Oh, this is where I use a switch statement. I'm now to competent. Now, I want to point out here that a lot of academic environments never get you past novice. I passed the test and I'm done. And unfortunately, that's where we have this big gap in our industry of not being willing to bring on junior people, is because we need some of these basic skills in place. And if all they have is the knowledge and they don't have them moved up to being competent with them, that they can realize now I need to use it and I can apply it in this context, nobody wants to put the investment into helping them get there. And that's a shame. And that's something I help businesses with, just as a side note, of course. Moving aside from picking on academics, if I'm now competent with my conditionals and I'm coding along and I say this switch statement needs a conditional or this piece of logic needs a conditional, I can solve this problem with the switch statement. Now I'm thinking about how do I fit this thing into this context, and that's what's filling up all of that brain space. How do I move forward? Well, again, can't shortcut it. We got to go back to practice it and practice it and practice it and practice it until what I'm having to use to fill my brain space with goes to becoming more automatic, more muscle memory, and it starts freeing up some of that space. And as I free up some of that space, I can start moving into the proficient level on the Dreyfus model. Proficient level they describe as holistic recognition. This is where you can see how all the pieces fit together, not just I can plug this into here. How does it all fit? And as I start looking at how does it all fit, this is the first time I'm at a place where I finally get to start applying some judgment. I get to start weighing, there's this solution and that solution. And this one may be a better solution than that one. No, in this circumstance, this one's better than that one. And I'm starting to do some of that, apply some of that professional judgment to my craft. In the Dreyfus model, they talk about at this level, they talk about you use axioms instead of rules. You know, at the beginning where it was don't forget your break, now you're using rules that help you go, this is often a better idea. This is a general guideline. They're much less hard and fast rules. A good example I like to give of this is a design principle that's very commonly repeated in object-oriented design is prefer composition over inheritance. Now, if you don't know what that means, because that's too coder for you, you don't have to. You just have to hear that first word, prefer. Prefer says, I have two solutions. I have composition as a solution. I have inheritance as a solution to a problem. Prefer, most of the time, composition is a better solution. I guess that would be that way. Sometimes that's not true. I have to make value judgments. This is the proficient level of practice. So, if I'm talking to someone about conditionals and they're proficient, they might look at this and go, okay, I only have one expression. I know here that a switch statement beats an else if ladder. That's a better solution. Either works, one is better. Am I doing the same conditional somewhere else? Maybe there's an even better solution. Maybe polymorphism, I can pull that out that way. Ooh, I'm not doing it somewhere else. Maybe polymorphism's too heavy of a solution and I should just use my switch statement. Which one is clearer to people when they're reading it? Which one is simpler? This is proficient level thinking. Oh my gosh, where do we go from here? There's two more levels. So the next level that we do this at, we go from here, it says, after I've been doing that for a while, I've been doing all this weighing for a while, it kind of takes a weird twist. From here, where I've been thinking a lot, you go to starting to get a feel, kind of almost a gut feeling. I see a situation and I get that gut feeling that tells me which way to go. And that's that automaticness starting to kick in again, right? We're practicing over and over and over. We're doing this all the time. And we're getting a feel for what direction we're going to go. And that's freeing up brain space because now I can lean on that feeling a little bit and use my brain space for other things. I want to stop here and talk about a challenge in this model. It's not a challenge in the model, it's a challenge in learning. And the challenge is this. Let's say I'm a novice and I'm just still learning, don't forget my break, don't forget the break, don't forget the break. And I have a problem. So I go to an expert and I ask a question about conditionals. And they start telling me, well, this feels like a better solution. And I'm like, why? What does that mean? And they're like, okay, I have to take a step back and think about why I have that feeling. And they start telling you about judgment. Well, this is better in this case, but this is better in this case. And there's all these trade-offs you have to make, and you have to think your way through this problem to come to these conclusions. Now the poor novice is back here going, don't forget the break, don't forget the break, don't forget the break. And this apple cart of ideas that they're holding in their working memory just gets knocked over. It's gone. And they got no value out of it. They got a lot more mess. And that's something that's really important to realize is if you're jumping between multiple levels of this model, it can be hard to build those bridges sometimes. I think we've all had that when we've been learning something new and we've gone to someone who's an expert and we say often, they don't know how to break it down for me. And this is why. And so it takes a certain amount of care and practice to be able to bridge that. And that's something I get to spend a lot of time on. So if I'm looking at this feeling and conditional at the expert level, I'd be code along, blah, 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 and be like, a switch feels like the best fitting, lightest solution to this. It'll adapt to change easiest. What am I using my working memory for? Well, that depends. Hopefully I want to continue getting better. And if I want to continue getting better, that working memory still has to be holding a piece off to the side, and that piece is for self-monitoring. I feel like this is a better solution. Am I done? Or am I going to look at it and say, how did that work out? Did that go the right direction? Are my feelings leading me the right place? And we're almost in a training loop on those feelings to make sure that they're taking us to the right place. So with that, when that training loop gets to the point where that's so automatic and I don't have to worry so much about whether I'm feeling my way to the right place, but I almost can sense whether I'm headed the right place or not, and that working memory frees up, that's when the last level hits. The master level in the Dreyfus model is when I have my working memory and my focus completely absorbed into the work that I'm doing. I'm not having to worry about self-monitoring. I'm not having to worry about juggling all of these pieces. All I'm worrying about is executing on creating this thing that I'm doing or executing on this skill. I can be wholly absorbed. You know, when I'm driving a race car, I'm not thinking of don't forget to shift and where my line is, and all that type of stuff. If I'm a professional race car driver, I'm only focused on me and the machine and the road and what I'm doing are one, and can focus wholly on where I'm trying to get to. And that's a master level execution. So to be able to make use of this framework, I want to kind of dig into the details a little bit of each of these things. We know how to move things along through their sequence. What are the skills that go into these areas? What do these categories really mean? When I first started building this, very much the programmer mindset, right? I wanted to find the perfect abstractions that would break these skills down in such a way that I found the magic set of skills. And I think there are some pretty core ones that go in there. But in the middle of doing that, functional programming, which was that academic thing I did back in school, became a very mainstream thing all of a sudden. And I realized that if there is a core set of skills, they're still so in flux that I don't know that I can pin them down. And other people who are better than me then tried, but of course in my conceit, I had to figure that I could do it, and I took a pass at it and I didn't. So I find this tool to be something that I want to approach in a very fluid, dynamic fashion. Tomorrow I may run across a new skill that I realize needs to go on here somewhere, and I can plot it on this and say, okay, well, it's a new skill. I'm going to put it on the novice, level over here, and I'm going to decide when I want to focus on moving it forward. For looking at what those skills would be, let's start with the craft aspect and the code craft. I said earlier that test for me, test automation was a programming discipline that was just a different domain, right? There's UI programmers and back-end programmers and mobile programmers and test programmers. So we have to know our domain. We have to know our test space. We have to know how we want to do smoke testing versus automated acceptance testing versus regression testing versus security testing, failure testing, resilience testing. I've seen matrices built by far smarter people than me that have a really good breakdown of what kind of stuff goes into this. But in order for me to build this, I need to know my domain. And if I'm in automation, part of my domain is growing my skills in well-crafting code, because I am building software and I need software well built enough to handle all of that change that we were talking about earlier. So I need to understand scope and coupling and decoupling and dependencies. I need to understand responsibilities and principles like single responsibility principle, dependency inversion, all of that kind of stuff. Those are all those skills I want to be working on in my space. I need to have some understanding of what actually is a well-crafted test. I mean, and some of those aspects we talk about in terms of, if it fails, what does that tell me? Is it muddled in with a bunch of other things, or do I know what actually broke? Is it likely to fail and not mean something's broke? Is it fairly isolated from other tests so I know what it's communicating? Can I repeat it? Is it consistent? All of that kind of stuff that goes into what is crafting a test well. And if I take that test further and I roll it into well-crafted automation, all the other pieces that go into with that, is it going to be clearly reported so we know exactly what happened? Can it be run independently without having to run a giant suite? Is it stable so that when it fails, people take it seriously and it doesn't fail nonstop all the time, and we know that 1 time in 10 is a real problem? What are all of those pieces that go into that? Tools is kind of an important one for us to take extra care on. And the reason I want to say this is because as an industry, we're a little like magpies. We like to jump on shiny objects. And that's not a bad thing, because we've made great strides by finding great tools. And there's a reason why we lean that direction. But as we're building up our skills in here, one of the things that's really important is for us to use good judgment and figure out if we're applying the right tool for the job. There's so many tools to choose from, and figuring out how to do it. And the vendors, of course, are all pushing how they have the miracle tool that will solve all of your problems and make you practically barely have to be there, click a few buttons, and you're done. And usually I've never seen that tool. I've seen a lot of AI stuff come out recently that are claiming to be that, and I'm not convinced on that either. All of those tools have trade-offs and applications, and figuring out how we find the one that's going to get us where we need to go, not because someone handed it to us, not because it's the one we're familiar with, because it's the one that fits the problem we're attacking. That's something that we have to put some effort into. Once we have that tool, are we even using it right? Am I using it in the most difficult possible way to try and solve the problem? Am I taking advantage of it in the right way? Am I fitting it to the solution space correctly? Is the way that I'm approaching using it correct? I think a really easy one to pick on here is Git. And the reason that Git is really easy to pick on is because I very rarely talk in a group more than a couple people where I don't get a reaction to this. Who in the room, by show of hands, has had a situation in Git where just this week, where you had your repository so messed up, you had to pull all of your code out of it, blow the repository away, reclone it, copy your code back into it, and then you could commit and push it in? If I've got 10 people in a room who all use Git, I'll have at least one, if not 2 or 3 people who say, yay, that was me. Now I ask a question, and I say, how many of you have ever sat down with your tool and with no other purpose than to practice how to use it effectively, how to commit and uncommit and change your commits and merge and fight your way through all of the different ways of applying that tool to what you're doing, because Git is not a simple tool and it doesn't come intuitively to most people. Usually not many people in the room raise their hand, and a lot of times it's 2 or 3, and it's very rarely the same 2 or 3. I'm not picking on you. I get hung up by Git all the time, but it's a great example of knowing how to use our tool and developing our skills with our tools so that they can really become a effortless extension of what we're doing, a powerful multiplier to make our effort more effective, all those things that tools are supposed to be for us. And sometimes we have to know when not to use a tool. Now, I'm not one of those guys who's going to say everything should be done in VI at the command line because that's what real technical people do, because I think that's silly. Our tools are there to make us more effective, to make us more productive, and they've been built that way and very effectively. But sometimes the cost of using the tool exceeds the benefits, and knowing when those times come is something that requires us to have an eye out for that and a skill for that. So we said they're very tightly connected, tools and technologies. Let's go look at technologies a little bit and talk about the things that we make our software out of. If we are in test automation and we're building code, then one of the technologies we're using is our language, and that's something we have to put some skill into, whether you're using Python or Ruby or Java or JavaScript or C#. It doesn't really matter. Developing our skills in that technology is something we have to figure out where we are, where we want to be, and how are we going to get there. Along with doing that, we have a great deal of tools that we can apply, or see, there I go, mixing up those terms. Technologies that we apply to build this. What would I bring to this? Am I bringing, if I'm building acceptance testing, do I want to do this with Cucumber? Do I know how to apply it correctly? Is that the right tool for what I'm doing? Or the right technology for what I'm building? How do I fit those technology pieces together? If I'm using, let's say, Selenium and Cucumber as an example for testing my website, is that, and I need to go into load testing, are those the right tools for that, or do I need something else? If I do, what is the need? What are the right tools, and how skilled am I at using those technologies? How does that technology fit in with my general application, and how do those pieces work together? I was recently working with a client who wanted to increase and improve their security testing. So what they did is they went out and got a testing suite, a security testing suite. They turned on all of the rules. They ran it across their existing software. It reported 10,000 security holes, and then they handed the report and said, come back to me when these are all fixed. I love those technologies that are helping us build that type of automation and that kind of testing into what we're doing. But how are we building the skill in how we use them? Why should we be using all the rules? Why wouldn't we use all the rules? How do we prioritize those rules? How do they impact what we're doing? How do they affect the overall application? There's a lot of skills and pieces that go into all of that. If I'm doing intrusion testing on a system that's in an isolated network, let's say I'm in a defense project, that is probably not going to give us a great deal of benefit. Those are the trade-offs we learn as we build those skills. And some of those technologies apply to specific methodologies like behavior-driven development or acceptance test-driven development or various, whatever direction you want to go with it. So how do we bring in, does Cucumber work with that? Does it sit on top of all of that? Is it one of the pieces we use under that? Do we have a suite of tools, and one of them is running Cucumber because it has those behavior-driven pieces, but there's these other pieces that don't really fit into that framework. How do we put all those pieces together? All right, let's dig into lifecycle. I think I said earlier, I don't love the term lifecycle because it usually brings the word process to mind, and I think it's a broader category. But while we're talking about it, we absolutely have to talk about process. This is how does what we're doing fit into the process of building our application? How does it work in terms of just the piece that we're building? How does that reflect the broader business context? Who are the stakeholders? How do all of those pieces work? Do we want kind of the agile concept of getting into an improvement iterative maintenance mode as fast as possible, or are we looking at it from a different angle? Are we trying to integrate this into a Kanban flow of some kind? All of these pieces kind of fall in this category. Also, on a much, much smaller scale, if I'm building out what I'm doing, my individual workflow is actually part of this dynamic, part of this life cycle. For example, if I was using test-driven development and I was trying to build out that red-green refactor workflow, that would all be a part of this as well. General aspects of the health of your system. How do you know that what you're building is healthy or isn't healthy? What happens when that goes on? What happens to the impact to your team? What happens to the impact of your business? What happens on the impact of how long can your project be? How sick before it's in danger of dying? What does that look like when it does? How would you recognize those symptoms and diagnose them? All of those pieces will go in here as well. Things like understanding bug clustering and looking for, if I use the metaphor of this picture on the screen, that one bruised area where we know something went wrong. There's also other pieces that go into understanding how we want to grow. Now, this picture is from the Kinnaman framework. It's okay if you're not familiar with it. I'm not going to go over it. But what it does represent is realizing we have different kinds of problems that we're trying to solve. And because of the difference in those kinds of problems, our approaches to how we go about them would need to adapt to them. And that's figuring out how to do that effectively is a skill in this category as well. One of the things worth taking a moment to put a little extra emphasis on is that it's not enough just to know my part of the life cycle. It's not enough for me to just know someone handed me something, I wrote the test for it, I wrote the automation for it. I have to see how all those pieces fit together to be able to deliver successfully. The DevOps world talks about this in terms of it being everybody focused on the same outcomes, and from development and test and operations and everything, all of us working on one team with the focus on our delivery and not getting siloed or distracted by all of the pieces in the middle. And the last area to talk about here is that professional area we touched on earlier. One of the things that's interesting about the professional area is it's usually the one we put the least effort on. And I think that probably the reason why that's a mistake was best expressed by a Google study done a few years ago. Now, I remember when Google was hiring by putting equations on billboards that were extremely difficult to solve. And if you could solve them, then they would deign to let you come in and talk to them because you were clearly a strong enough technologist that they might be able to find a place for you. And then they did this study of all of their teams and said, what attributes on our teams are making the team successful? Which pieces make them perform highly? Which pieces make their outputs good? Which pieces make their team members happy to be there? And they found that of the 8 characteristics that the best performing teams had, the first 7, the highest 7, had nothing to do with STEM skills. They were not technology, they were not math, they were not any of the things that those billboards would say they were hiring for. They were all the soft stuff. They were all the emotional intelligence and the collaboration and the team stuff. And a lot of that falls here in this professional category. And so I use that as an example to show that to get to that high level of performance and maturity as a developer, or as a tester, as an automator, this area is one that you absolutely cannot overlook. It is so crucial. And just kicking that off from the top, working with others, being able to collaborate effectively with your team members, being able to communicate with the people outside of your team, with your stakeholders, with your users, with non-technical people, all of those working with others pieces. They're skills. Some people learn those skills easily. Some of us have to work harder for them, but they're skills we can develop and we have to focus on. Also in the professional category is how we do our work. How do you plan your work? How do you estimate your work? How do you organize your work? How do you pace your work? How do you know when you're slacking off? How do you know when you've pushed too hard and the best thing you can do is walk away, because you're going to do more harm than good if you just stubbornly keep going forward? All of those pieces are part of those professional skills that are crucial to be successful. In that also is the ethical component. Should you be doing the work? Is the work you're doing appropriate and responsible? Thinking and judgment. Again, focus on things that are not necessarily technology centric, but the way that our problem solving skills, our systems analysis skills, our systems thinking skills. How do I decompose what I'm looking at? How do I compose the pieces I need into what I'm looking for? How do I navigate a tricky, complex landscape? All of these pieces are not exclusive to software by any definition, but they're definitely things that we need as professionals to be effective in what we're doing. So that's our framework, the mastery wheel that we use to be able to help professionals look at what I hope is a longer scope, a bigger picture of a technology career. A lot of people get to a point in their technology career and they say, I'm a senior developer, I'm a senior automator, I'm a senior tester, what have you. And they go, there's nowhere for me to go from here. I guess I could become a manager, which isn't even career growth, it's career change. And we lose a lot of good people out of the profession because they hit that point and they get stuck. But when you look at our field, a lot of times if you get that senior title 3 to 4 years into your career in technology, and that's just crazy when you think about it. Because as an engineer, you're not even eligible to apply to take your licensure exam. Forget being a master engineer, you're not even a professional engineer, you're an apprentice engineer. Same thing for doctors, lawyers, therapists. An electrician has a 4-year apprenticeship that they work supervised before they can apply for licensure, along with classes that they had to take and tests they have to take before they're allowed to work independently. 4 years. At 4 years, we say you're a senior developer. And I hope we painted a picture of, at 4 years, you probably have a lot of range of growth still available to you in that mastery wheel, in terms of the skills that you want to develop, in terms of how you grow as a professional. And I hope that you will. And if I can help, please reach out to me for you or for your business. And thank you for spending this time with me.